Now let's look at part C of this question. You can pause the video to read the question. And this one has no relationship with the previous questions either. So yeah, it is here itself. So yeah, let's work on it. The frequency of a photon will have to be more than the threshold frequency of an electron to be released. Discuss the statement in terms of underlying physical principles. The prerequisite is here. When X-ray photons hit calcium, electrons are released. This is my favorite part. One of my favorite parts about it. It's about the mechanism behind a phenomenon, behind a kind of concept, right? Now, to analyze it, we can use we have this. So we have EK max is going to be HF minus phi. Now remember, in order to have the EK on the left-hand side, you have to make sure that this part is greater than 0. So we have to make sure that the right-hand side is greater than 0. And now, for if you shine a light, a photon of light on a metal plate, the phi is a constant for that metal, the work function. So it means that the photon has to, the frequency of the photon has to exceed a certain value to overcome the work function of this metal, right? Remember, when I introduced this work function, I call it like the resistance energy of some metal, right? So maybe you can write something like this here on the lines. Discuss this. Okay, so a photon. Okay, maybe let's just start from frequency. The frequency of the photon, the frequency of a photon has to exceed a certain value. We call that value actually threshold frequency, right? Threshold frequency. To make sure it overcomes the work function of a metal, so that the photons can eject electrons, so that we see this photo emission, so that we see this photoelectric effect. Yes, this is kind of the very basic idea of PE effect, or the beautiful thing about it.